Good evening to one and all. Thank you for your patience. We are on the second day of our FDB program. Few instructions for the participants. Please mute your audio and turn off your video while joining as well as throughout the webinar. At the end of the session, you can post your queries and questions in the chat box. Please do not switch on your mic to ask queries as it will disturb the talk. Kindly pin the presentation of the speaker to see his slides. Please do not leave the meeting in between. Thank you for your cooperation. Let's start our meeting with a small prayer. Dear Lord, we surrender this day to you, Lord. Shower your abundant blessings upon us. The Lord will perfect that concerns me. Your mercy, O Lord, endures forever. Amen. Now, I would like to invite our ever enthusiastic Director of CICRST, Dr. Han Aina Avril, Dean of Science, Associate Professor of Zoology, to welcome the gathering.
Thank you, Emima. This is the Lord doing. Thank you, participants. I ask each one of you a big sorry for yesterday's inconvenience. That is due to the glitch of the network going dipping down. I don't think today we'll have any problem. And welcome back. The second day. We will begin shortly. Before I could hand over the session to Dr. Inigo to introduce the speaker, I like to cheer up certain people who were doing their interaction during the person who was presenting. That is, they were putting lots of questions in the chat box. Among them, the best interactor of the day is Dr. Pichamani Angir Kani, Associate Professor, Lady Doak College, Madurai. A big applause to Dr. Pichamani Angir Kani. The second best interactor is Miss Rohin Sahai, researcher, VIT Velo. And the third, proving that Holy Cross College is also there on the podium, is Dr. Bonita Cooper, Assistant Professor of History, belonging to Holy Cross College. She was the best third interactor in the chat box. A big applause to you, dear. Then, among the assignment who participated, the topmost is Dr. Rajalakshmi from the Department of Biotechnology. She is the coordinator. Then the next one is Miss Mercy, the Computer Science Department of our own Holy Cross College. Then comes Mrs. Sybil Ignatius, the Assistant Professor of Department of Zoology. The fourth is Arish Chandran Anandaram, Assistant Professor in Sri Krishna Arts and Science College. Next, the fifth in the row, Mohana Lakshmi, Assistant Professor of French. Then, Dr. Bhuvaneshwari, belonging to the Department of Zoology, Bishahipa College. A big applause to you. We'll see as the day to come who is going to get the first 3 award. Over to Emima. Thank you.
Thank you, ma'am. I would like to invite our ever supporting head of the Department of Physics, Dr. Inigo Meririta, to introduce the guest speakers, Mr. Kudiyarasu and Mr. Dennis Gerald.
Thank you, Emima. Good evening, everyone. It's a privilege for me to welcome you all for the second day of the Faculty Development Program on Artificial Intelligence and IoT Heuristic Transdisciplinary Perspectives. Let me first extend my thanks to our Secretary, Reverend Sister Dr. Niranjana Anthony and our dynamic principal, Reverend Sister Dr. Christina Bridget, for their constant support and encouragement in conducting the program. I take this opportunity to welcome the Director of CACRSD, Dr. Ayana, for the initiative taken. The quality of a person's life is in direct proportion to their commitment to excellence, regardless of their chosen field of endeavor. It's a great pleasure for me to introduce our today's speakers, Mr. Kudiyarasu Murugesan and Mr. Dennis Gerald, who are going to talk to us on the topic IIoT real-time use case in renewable power and industrial automation. Mr. Kudiyarasu Murugesan is the head of Wind Solar SCADA team in Siemens Gamesa Renewable Energy, which controls over 60 gigawatts of wind power worldwide. Over 21,900 wind farms monitorized in 55 countries. Sir has 18 years of experience in automation and renewable sector and a solution expert in IoT. He is also expertised in embedded programming and protocols and IoT solution architect in analog sensors IIoT enabling. Welcome you, sir. Our next speaker is Mr. Dennis Gerard, who is a SCADA engineer with 7 years of international experience in automation and 3 years specifically in development, installation, and maintenance of SCADA system of both wind and solar farms. He started his career as an operation lead in Al Manzoori Specialized Engineering Muscat and worked as a project engineer in MEL Systems and Services Chennai, and currently working as an international coordinator for the Northern Europe and Middle East in Siemens Gamesa Renewable Energy Spain. Adding gem to his crown, he is a certified helicopter pilot also. Welcome you, sir. The mark of a true professional is giving more than you get. Once again, I welcome you all.
Thank you, ma'am. Kudiyarasu sir, the platform is yours.
Yeah, thank you, Inigo ma'am, for this warm welcome. Good evening, all. I'm really happy to welcome all in this wonderful Sunday evening. Happy to know that your active involvement in learning the new things on IIoT platform, right? So as we know, so nothing is great in the world other than learning and teaching others. The great job you are doing. I'm really happy that I had the opportunity here. I want to thank our director ma'am, Lona ma'am, and our principal Christina ma'am, and the professor Emima, who approaches for this wonderful opportunity. And I want to thank again Inigo ma'am for this warm welcome. Right. So today I'm going to, I need to share, right? I'll take it. Hope will you able to follow my screen?
Yes, sir. Yes, sir.
Yeah. All right. So in IIoT, if you ask, it is a part of the evolution actually. So to bring more clarity on this IoT part, I thought of explaining how the industry evolution has been started and where we are now. So that will give you the clarity that what exactly we are discussing about IIoT platform. So speaking about the industry 1.0 is originally started at 3 centuries back. The first evaluation is a mechanical evaluation, right? So it mainly on the mechanical part. So it contains hand looms and mechanization of taking the equipments from the unmanned to mechanical parts, right? That it comes to the second part, the industry revolution 2 is the one of the important part in the industry evolution, right? Why? Because the first modern power station, that electrical power station, which was built by the English electric engineer, Mr. Ferranti in 1891. So that that gives the industry into the different level. So that's why the second industry revolution is started at between 1870s to 1914. That's how our today's market is deciding that the industry 2.0. Right. The first one is the mechanization. The second one is the electrification. So once we got the electrical power, then we have a very much of energy to build the assembly lines, and the mass production is originally started there. Right. These, apart from these two industry evaluations, the third one is the very much important, because here it comes that semiconductor and the integrated chips. This play a major role in our life, right? Most of the guys, we know that all our equipments, which is the part of integrated circuit and the semiconductor. Without that, we cannot do anything, right? So that's why this 3.0 is, people are telling that it started at 1969. That is in automation and the computer and the electronics. So basically, it is combination of mechatronics. We will say it is a mechatronics. So mechanical and electronics. Sorry, is this fine, my voice?
Yes, sir. Yes, sir.
Okay.
Dear sir, you can continue.
Yeah. Thank you.
Participants, kindly mute your audio.
Right. So basically the 3.0 people will tell us a mechatronics, because it is an evolution of mechanical and electrical and electronics. It is combination of all three. So there we can say that CNC machines, PLCs, and computer hardwares, which is the part of the 3.0. So maybe in the late 70s, the people who know that was the invention time. So they started knowing about the computers and the electronics. So that here the part base build for the industry 4.0, right? So industry 4.0 definitely needs the data. The 3.0 is the base for the collection of data. So in the till 2.0, we don't have a data to which we usually collect those data and we'll keep the data for the further analysis, even for manual analysis. But in 3.0, that makes possible because of the computers, because of the electronic devices, because of the PLCs and CNC machines. So in the CNC machines, we are doing programming in the sense we need to keep those programming for further analysis. In that way, we can collect those data and we can keep it for the further analysis. The only thing in 3.0, the data will be part of the industry itself. So if you take a manufacturing industry, in that industry, the data will be kept aside, right? It is not used for further analysis. That comes the industry 4.0, where we are now, right? So it is the part of, it is the evaluation of 3.0, and there the data will become as a information. So without the information, we cannot take a decision. To take the decision, we need to convert those data into the information. How we can convert that data into information? That's explained in the IIoT, ML, machine learning, and the AI, artificial intelligence. So here comes all the three, right? So that is why we are discussing today how we are converting data into information and information into decision, right? So I'm moving to the next one. So to explain better on what is AI, because everybody is keep on listening about artificial intelligence, machine learning, IIoT. What exactly? What is the difference between AI, machine learning, IoT, right? So where it plays the major role, right? So any architecture of these industries, the base zero is a sensor, right? So we have many types of sensors. Basically, if you since I see that most of physics professors are here, so our basic majority of the mechanical sensors is based on resistance, capacitance, and temperature. So other than, so few other vibration sensors also there, but majority today industry environment, if you take any temperature sensors, so that majority of the sensors are resistance only. So now the sensor what we have today, so that will sense that pressure or temperature and everything in resistance and it converted to the 4 to 20 milliamps. So that is the technology of 3.0. So that's how right now we have the data, right? So what is the machine learning? The machine learning is nothing but we take a few parameters to study a machine performance or behavior to give a more clarity, right? So I'll give you an example. So most of us we are using mobile phones, right? So in the mobile phones, many of us in recent mobile phones, you can have a face unlock, right? While buying a new mobile, you have a face unlock. So the first time it will register your face to unlock the phone, right? So yeah, if you are keep on using for 2-3 years, right? It never say even if you the first time while registration itself you have a long hair maybe, right? After sometimes you will go for a haircut or you will lose your weight. So whatever it may be. So day-to-day basis, it will learn your face, right? What is the changes happening in your face, right? So it will keep on sense the data from the source and it will correct the model. So that is the functionality of the machine learning. If in the industry case, if you take a generator or a motor, this motor will run on 1500 RPM if you give a voltage of 230 volt. So that is an ideal condition, theoretical condition. But because of the wear and tear, so this may get reduced. The running RPM may be get reduced. Because of that, we cannot say motor is not running. To make this understanding, we need to write a piece of code to learn the machine functionality for a while. If that machine functionality is going out of the threshold, then this will create alarm, right? This is a piece of code. So this is, I'm just explaining a simple example, right? This is a one part of the functionality. So similar to that, we have n number of functionalities. That n number of machine learning codes will be taking care of analyzing the models, right? Analyzing the performance. So any physical performance can be learned. That's why it is the name as machine learning. It will learn the performance and it will correct the actual setting into expected one. So what exactly AI? AI is like a brain, right? So n number of machine model can create simple algorithms and it will send a communication to the AI model. What AI model will do, this will take a decision. What happens if, for example, if we are giving 230 volt and the motor is running at 1500 RPM, suddenly the motor is going for 3000 RPM. So that is a deviation because in machine learning, it will keep a threshold of plus or minus 10 or 5%. If something goes down, whether it is going to 0 or it is going to 3000, something is abnormal. In that case, machine learning will give an alert to the AI. AI will take a decision based on the previous record. So to give a more clarity about in the AI, most of us will search in the Google for the restaurants, right? If you ask the Google for suggest for the restaurant, this will take a suggestion of, so what are all the restaurants so far you went? What are all the ratings you already given? What are all the ratings already the people who are around you, they are already given to that restaurant. These things are considered and this AI and even it take the consideration of you are traveling from which direction. So if you are moving out from Chennai, then this will suggest the restaurants which is on the left side. So that's how the decisions will be made based on the data which is already collected and machine learning is predicted. All the combination of these data will be taken into the information and AI will determine the result and the actions. Then what is IIoT? IIoT is nothing but connecting all those devices into a common platform. That is IIoT, right? The machine learning is a part of code. This will do the and this will run a learning progress. It is acquiring the data from specific tags. Like if for example in the industry, if you have thousands of tags, only 2 tags is required to know the RPM. So RPM tag and the voltage tag. That's 2 tag is enough to run a simple machine learning model. So like that we can run a n number of model. It's up to the developer who is working on that and the management who is taking a decision on that. So this n number of mission model is going to connect to the artificial intelligence. Connecting all to in a common platform is the job of IoT sensors, right? So here maybe you will get some bit clarity about what ML, what AI, and what is the IoT. Coming to IoT, MQTT broker is the common platform most of the industry peoples they are already using, right? So we'll discuss more on the MQTT brokers in the next slide, right? So as I said, IoT. So IoT, if you take it to the Wikipedia concerns, right? So the system of interrelated computing devices, ability to transfer data over network without human intervention. It means that any devices, sensors, so that can connect individually to the internet and it can transfer the data, right? That may be your mobile, that may be any sensors, that may be any of your driving cars, right? Or any of your weather stations, right? Whatever it may be. So any device which connected to the internet and transfer the data over network without any human intervention automatically, right? So that is an IoT. It is similar to IIoT also. The only difference between IoT and IIoT is the IoT is mainly concerned about the domestic products like smartwatch, like baby monitoring camera and mobile phones. Most of the people we use the smartwatches, right? And smart home applications. So everything, whatever the thing which is mostly discussed about the domestic appliances, these are all called IoT. What are the IIoT in the sense? The sensors, the PLCs, and SCADA, MES system. So lots and lots we already having in 3.0, but we have most of the devices which is not interconnected. So that is the IIoT get into the picture. The one major concern here, difference between IoT and IIoT is if something fails on the IoT, it won't affect. It won't affect in the sense the failure. It's limited to the product, right? If something goes wrong on the IIoT part, it may lead to the catastrophic event, right? If you consider any of the PLC, which is going to control a pressing machine in the industry, it fails to detect the sensing people putting a hand inside the pressing machine. What happens? So this will lead to the safety event, right? So that is the only difference between IoT and IIoT in case of risk, high risk concerns, right? Then so I'm just going to explain about the IoT protocol. So there are in industry there are n number of protocols available to transfer the data between the end device to the field device to the edge device. This maybe the SCADA server or the central SCADA server, any of them, right? So in currently in industry practice from 3.0, we have n number of industrial protocols like Modbus, right? Field bus, massive bus. So many protocols are available, right? So what's special for IoT protocol? So the legacy protocols, which is developed by the manufacturers, most of the protocol which is developed by the manufacturers of the product. Like if Schneider PLC is there, they have their own protocol. The Siemens PLC is there, they have their own protocol. So what happens, right? So these protocol, the only talk with the Siemens SCADA. Siemens PLC will only speak with the Siemens SCADA, and the Schneider PLC will only speak with the Siemens the Schneider SCADA. So there is a proprietary thing is there. So in that case, in the IoT protocol, the people they are very well defining the IoT protocol itself. People very clear about that. Wow, the IoT protocol should be how. right? The first category characteristics of this IoT protocol is it is open for implementation, right? It means that if I'm going to write a piece of code to driver code to collect the data from the field devices, right? So I should use this protocol to collect the data without any third party or any copyrights. So that is the first criteria for the implementation. The second one is report on exceptions. What it means in the legacy system, the PLC will collect the data from the various sensors. Maybe probably in next slide I will explain how the sensor are connected to the gensets, right? So that will give much clear idea. The report on exception is whenever there is a change, then only the data will be pushed to the server. Otherwise, it won't send. So that makes sense, right? So why I need to keep on sending the data without any change, right? That is a data garbage, right? So it will store the data in the server and that will be garbage, remain same. Why I need to see if the temperature is always 30 degrees for 4 hours? Why I need to see the data for 4 hours? Instead of seeing the data for 4 hours, I need to know only if it is for a 12 o'clock it is 30 degrees and 3 o'clock it is 29 degrees. That's enough for me because that makes the purpose. Then the third one is lightweight. It should be lightweight because in the IoT sensors, which is going to be the end device, right? These are all the device. We don't have much sophisticated cost to develop to the high end of devices and the power constraint. So in that case, people more conscious about developing the protocol. So what is the payload it is going to carry? It should not be highly sophisticated protocol. It is lightweighted protocol. It can carry only 50 to 100 bytes. So that may be the sense because it is not going to collect 100 devices into that. It is going to send only their own data to the data collector, right? So this part, there are n number of protocols, IoT protocols available in the market, but I'm referring only few because of most protocols which is commonly used in practice, industry practices. The MQTT, one of the most used in all the industries for the IoT implementation. The next comes the OPC The REST and COPE are still people are using, but not in the volume, right? So this come to the IoT protocol. So what the IoT protocol is? That protocol which used to transfer the data from the one device to the central server. So this is the protocol for the IoT sensors. Right. Next one is I'm just going to explain about what are all the wireless communication interfaces nowadays used in the IoT sensors. Right. Since I said it is an end device, so end device should be lightweighted and it should not we won't have get that much of flexibility to lay the cable in the various places, right? In that case only the wireless comes. So if we have a smart device, if you let us assume you have a tracker watch, so let us assume if you have a cabled and it is connected to the computer, how it will be working out. So in that case, the wireless communication is much important and power also much important. So there are 5 major wireless communication interfaces which is commonly used in the industry. I'm just listing. Some of them is used for industry purpose. Some of them is used for the uh, domestic applications, right? So the Wi-Fi, all we know, everybody having in our mobile. So through that we are transferring the high bandwidth data, like we are streaming the videos, we are seeing the YouTube videos and Facebook, WhatsApp, whatever we are seeing. So this plays a major role in higher bandwidth and but in a shorter duration. Maybe 50 meters and 100 meters is the max, right? So the next one is the sub gigahertz. The sub gigahertz mean less than 1 gigahertz data transfer, right? So this kind of communication usually used in the industries where the data needs to be transferred for kilometers, for 10 to 5 kilometers. This need to travel in the sense. Then we use the sub gigahertz, right? So the advantage is it can penetrate to the buildings. So, but if in case of Wi-Fi, if you have a strong walls, it won't penetrate. So that is the advantage of sub gigahertz, but disadvantage of sub gigahertz is it won't carry much payload. You cannot run videos, you cannot run high memory files and everything. Right? We can use the sub gigahertz for some kind of sensors can transfer the data, like the flow meter is which is kept in the remote places, right? So from the remote places to if you need to send the data to the HO, then it can push the data once in an hour, then it go in a sleep mode. In such kind of applications, sub gigahertz or LoRaWAN will come in. Right, all we know about 3G, 4G, and we are just waiting for the 5G, which gives a major breakthrough in the remote places where we install the devices. Because that is a great challenge for us. Usually, if you compare in Tamil Nadu, it's far better. If you go across India, you cannot see the major places. You don't see the 4G. But in the recent evaluation, we are seeing that wherever we go, we can get the 4G in the sense where that is the possibility of the exploring the world, right? From wherever we can place your device can communicate to any part of the world. That's how we are getting much better advantages. And BLE is the one of the least power devices, right? In your smart watches, usually which is connected through BLE only. And LoRaWAN is the device which is used to placed in the miniature IoT industrial devices because of their lesser memory consumption and the lesser data sharing, right? So this is up to IoT communication. Next one, I'm just going to explain about how the genset industry, which is operating in 3.0. So next, once I complete this explanation about how the service operation is happening in 3.0, then you know where is the gap, right? So based on that, I'm going to explain about how this is mitigated in industry 4.0, that is using IIoT, right? So this is very simple, and I'll explain, take bit time and explain about how the existing industry practice is going on in majority of the places, right? Which is in the 3.0. So that you will know where is the gap, and that gaps how it is addressed in 4.0, that I will explain next slide. Okay, this is a simple genset which is going to connect it to sensors. One of the sensor is lube oil sensor, which is used to measure the pressure, oil pressure in the genset. So genset, probably people will aware that diesel genset I'm referring, which is used in the most of our commercial buildings or industries or in the hospitals, colleges and schools and everything. To once the power grid fails, it will run automatically and generate the power to the buildings, right? So I'm just going to discuss about how the service industry is working on the diesel gensets, right? So this is the first sensor. The second one is the RPM sensor, which used to measure the RPM generator and coupled to the engine to analyze. So basically, for RPM sensing, there are two methods now in the industry. One is the sensing through proximity sensors. Any metal contact which comes closer to the proximity, it will detect the count, right? So that's how we can count the revolutions per minute. So usually in industry right now, 3000 RPM and 1500 RPM is the only two variations which is available in the industry, right? So next one is the WTG sensor, that is water temperature gauge, which we say it as a water temperature gauge, which is used to measure the water temperature. So maybe this may be not relevant, but just to explain about the sensors, so that will help you to understand more about how this is physically connected, how this is going to be IoT in the future, right? The next one is the fuel sensor. You might see that in your cars also, the float will be there that will detect what is the fuel level and it will send to the dashboard, right? The similar kind of float fuel sensor will be there in the bus. The next one is the vibration sensor. You may not see this vibration sensor in the old genset, right? So in recent gensets, people, they have installed this vibration gyro sensor. It will give the X, Y, Z coordinates, and based on the vibration, you can detect. So is there something goes wrong? So that is the basic idea about this vibration sensor. Okay, right? So then it is in a battery. Yes, this is a important part, heart of the system, because without battery, you cannot crank and start the genset in the on time, right? So to monitor this, it is also connected to the control system. Then next one is the multifunction meter. This is the meter which is used to measure the voltage, current, frequency, and power factor which is produced by the generator. So why it is needed? If it is in a rental generator, it is going for some rental. These guys need to know how much energy is evacuated from the genset to billing purpose, right? So all these devices, so except the multifunction meter, everything is connected to the engine controller, and they place the data logger over there to collect the data and send it to their control center, right? I'm just explaining about the only one genset. Similar to this, there are n number of gensets which is connected to the control center. For the simplicity, I am putting only one generator here. But in real service industry, generator service industry across the India, maybe they may connect 1,000 generators to the one central location. There will be a control center team, right? So usually they will place a data logger in each of the genset with the 3G or 4G SIM cards. This will send the periodic data and alarms and warning to the control center, right? So this control center team is the second layer, right? This is the up to generator is the base 0. So this is the first layer, and second one is the control center layer. These people will do the analysis, and they will keep on monitoring about the any downtime of the generators, or they will prepare reports how performing all the sites are. So this is the job of the control center team, and they will also send alert to the technician in case of any breakdown or failure, right? This is the second part of the uh, this service operation, right? The next one is the important is ERP, right? The ERP system is responsible for having the data about the purchase systems, right? And they will maintain the inventories. So if some of the material which is coming to the company, that should be in the inventory, right? All the inventory details will be managed by the ERP system, and it also has the supplier information, right? All the supplier information will be there in the ERP system, and space, how much space we have, all these are handled by the ERP system. And additionally, this will have the details about technicians who is going to handle the service operations. So if any case, if in any case there is a fault happens, right? So the ERP system should be accessed by the service technician to enter the faults, right? So if let us consider one simple example how this will operate, right? If any of the turbine, any of the generator is got breakdown, it is failed to run, then it will send this data logger. This data logger will send, just a moment. So this data logger will send the alert to the control center. The control center team will see that alert, and this will send the alert to the service technician, right? Once service technician receives the alert, he will get some recommendation from the people who is working on the shift. This will not be fixed based on the competency level of the person who is working on the shift, right? He will receive the alert, and he will take this recommendation and go to the space, right? So once he reach the space, and he can able to see whether all the space are available or not, right? Because the data which already are in the space, which is not open to the control center team, they don't know whether it is available or not, right? So once he reached there, then only he knows that if something is missing, then he has to initiate the request to the ERP system for the procurement, right? Then they will talk to the procurement. Then they have their own process. It will take a own time, but until that the system will be down, right? Why this is happening? Why? Because the ERP system is a system. It has the data on its own, right? It is not sharing to the technician. It is not shared to the alarm and the reports. And similar way, the ERP system doesn't have access about the generator sensors, right? So how this is performing? They don't have the reachability. for example, we can say this is a data silo, right? So data are available, but which is not openly shared to the departments, within the departments. There is no transparency between the departments. So there is no one is there to take a decision. Central system, there is no central system there to take a decision about so when it was happened, what is going to happen in future. That is also there is no. So that is the gap. So that's come. So once you go and see the KPIs, right? So if you measure the KPIs of this legacy 3.0 system, usually the KPI of service industry is captured by three main key parameters, right? These key performance indicators are availability, MTBF, and EBIT, right? So I'll bit explain about this KPI because it may not relevant to that, but as a service industry, this should be the key things, right? Availability. So availability is nothing but it has to be the system is ready to run, right? The system is ready to run hours, and actually availability of the system ready to run hours, and how many of the hours which is not available on the available hours, right? That is called availability. So if the availability affects, right? So then the contract what we had with the customer, that it may be affected, right? In the 3.0 we have a reactive approach, so that's why the availability are matter. So what is the reactive approach is whenever the problem comes, then only we will react, right? But this is the gap, right? In the future IoT system, this can be addressed by the proactive approach. That's why that's how we are going to see in the next slides, right? So the first KPI is availability. This should be 100% uptime as per the contract. If something goes down, that will be penalized by the customer. The second one is mean time between failures, right? What is mean time between failure? So between the failure, what is the time, average time it is taken? If it is lesser, it is worst. If it is high, mean time between failure is high, that is a good. If number of the MTBF decreases, it increases the operation cost. It means that number of travel is happened more, right? Because of the more travel, the cost will be increased. And next one is a service EBIT, and this is earned before interest and tax. What is the benefit? So obviously, if MTBF reduces, our operation cost will increase. Then our negative impact and the EBIT will be reduced, right? Our profit will be reduced. So this may be the off topic, but since I'm explaining this because of the service industry, right? So I'm going to tell you that how to convert a normal sensor into the IoT enabled sensor. What is the basic characteristics of the enabling IoT sensor? So I'll just explain what is the normal. This is the float sensor which is used in the fuel tanks. This is the resistance based. Whenever the fuel level comes high, this float may come high and it will go down. So based on that, the resistance will vary here. By varying the resistance, we will map the resistance to the fuel level and we'll tell to the controller, so this is the fuel level. So that's how the legacy system has. But so if you convert these IoT, this fuel system into the IoT system, so what are the benefits you will get, right? So before going to that, what for a characteristics of IoT sensor, there are three qualification is needed. The first one is it is an intelligence. What it means? This is the analog sensor. It doesn't have any intelligence, right? There is no decision making here. But if you put a smart sensor, this will sense the capacitance value between the pipe, and it will convert the capacitance into the fuel level within the controller itself, because they are going to deploy on small microcontroller. They are going to write a piece of code in the small microcontroller, and with that the result will get a smart value from the sensor itself. Whereas in this case, we'll get the resistance only. We'll move this resistance to another controller. There we have a mapping and we do the data, right? Whereas in here, as intelligence, it has some kind of microcontrollers to compute and to analyze things, right? And it can also send their own health. What is the temperature inside? the device. What is the ID, right? Each and serial number of the device. So these things can be sent through over network so that it will be easily identified. That's why the unique addressing come. What is in the unique addressing? If you have in the plant, if you have a plant with 150 machines and 2000 sensor which is already connected to the machines, if you have a unique addressing, you can pinpoint which sensor is failing that from the central location. So that is the main qualification for the IoT sensor. Each IoT sensor having a unique address to reach that particular sensor from the remote location. And the third one is report on exception. As I explained earlier, if there is a change, then only it will send the data over network. Right? So this is the IoT enabled smart solution. In earlier case, we might see that all the sensors are connected to the engine controller, right? If you see in the now in this case, all the sensors are connected to the MQTT broker. MQTT broker is the IoT enabling central controlling of the system. This will collect the data from all the devices, right? So directly this will connected to the MQTT system. All the sensors are directly connected to the MQTT system. Since I said unique addressing is there, so you can map the particular device. So which sensor, which make of sensor is connected to the which genset. That decision can be made from ERP system itself. But in the earlier case, ERP system won't access to the DGs and sensors. So that this ERP guy can do the analysis, the failure happened in which type of sensor and which batch it was and how many times it was failed in a month, or what is the how this is worst or best compared to other suppliers. This kind of flexibility is because of the IoT enabled, right? All the sensors get connected to the broker and the central system also connected to the broker. On top of that, we have a machine learning and AI, right? In earlier case, this guy, right, our technician, get the support from the central system to resolving the issue. But again, the decision which is taken by the control system team is not authentic, right? It depends upon the guy who is in the shift. But if the decision makes by the ML and AI system, this will be permanent, right? So based on the previous data, he will do the analysis. He will give the recommendation. Hey, guy, go and do this. This will solve the issue. And this is not only the way. And as I said, this will give you a predictive alert. What it means, the predictive alert, right? If I have all the devices are connected to the MQTT broker and the servers, the server will do the analysis, right, of all the sensors connected devices. This will run a statistical algorithm and find where is do the standard deviation in, and they can find that which sensor is deviating from other sensor, right? All the sensors are running with a similar sensor, but one particular location sensor itself going deviating from others, then it means that it is going to fail soon. So that time can be that time can be considered, and that decision can be made by this machine learning and AI machines, and it will give alert to the technician. Hey guy, you are going to the servicing the second DG of the sensor. So why not you can do the service at the same time before failure? That prediction can be given to the service technician. That is the power of the IoT enabling, right? So why? Because all the system are centrally connected. That is the advantage. The data silo will be broken here. So everybody can access the data. Central system can access the ERP data. ERP can access the engine data. Engine can get the data from the ERP and the central system, right? This is the advantage of IoT enabling. So I won't say that now in majority of the places we move to 4.0. No, this is the starting point where we are, right? So next one, I am going to explain bit about the MQTT protocol, right? So to explain in the simple word, most of us are using YouTube, right? YouTube, and Facebook, and most of the cases, right? So what you are doing while seeing the video in the YouTube? So if you like some of the videos, you subscribe, right? So whenever that subscribed channel, it has the new video, you will get alert. Simply it is working based on the MQTT protocol, right? Similar one I'm going to explain here. The sensors, whatever the sensor, it has the data change, then this will publish the data to the MQTT broker. If you assume this sensor, this will publish the data to the broker, right? So the sensor may be the temperature sensor. If these guys needs those data, you just assume. If the clients, all the clients need the temperature sensor data whenever there is a change. So what they will do, right? They will subscribe the temperature sensor data in the broker, right? So whenever this client send the data to the broker, immediately it will be delivered to the all four guys. So all the four guys immediately will receive the data. So whenever he is posted the data, that's how the broker and the client mechanism. The broker, MQTT broker, is a simple server, right? This will wait for the client request, that is in a published message. Once client publish the message, this will collect the data and will check the entry. Overall, subscribe the data. So based on the subscription, it will deliver the data in a mass, right? You cannot believe that millions of connection will be published in a 10 to 15 seconds. That much powerful the MQTT broker is. So that's why the world is keep on moving towards the MQTT. So to make the IIoT enabled, right? So as I said, the same thing is here: report on exception and lightweight. This is one of the advantage of the MQTT protocol. Then, what is the future trend for IIoT? Since I'm here in the webinar with the professors and who are leading the colleges, so this is the right time to tell you this: how the industry is growing, what is the expectation of industry, where we are now. See, this survey is taken is something between 2015, and they have taken for 10 years. So what is the expected growth, right? So as it is started in 3.8, and now it is in 9.9 billion devices, internet connected devices in the world. And it is expected to 21 billion devices, IoT enabled devices, is going to be the future, right? Then we see what is the potential for the engineers and the sensor developers is required. How much sensors need to be developed, the IoT enabled sensors need to be developed, right? And this is majorly discussed about the various technologies and everything, right? So to give a bit clarity on this, and IoT enabled sensors and non-IoT enabled sensors. If you see this trend in 2015, you see non-IoT sensor is 10.1 billion devices, right? So for 10 years, it will increase only to 12.7. It almost 2.6 billion only it increased. The market seems to be saturated, right? So it is almost saturated. So if you see this red one, these are all the IoT enabled devices, right? So in 2015 it is 3.8, and now it is 9.9 billion, and within 5 years we are expecting double the amount of IoT enabled devices. Here comes your part, right? So we need to understand the technology. So what exactly IIoT, and how this is going to play in our life and industries and world across the world to change the trend. So we need to understand and we need to educate the people towards the IIoT, and so make the world very smart, right? So this is not going to be stopped, and probably this may increase in exponentially. So we can assume that now most of us know that maybe in not in India, in other countries, the people are monitoring their babies through baby monitor camera. This will definitely reach India in maybe 1 or 2 years, right? May not now itself people can do that. But you can also see the mobile devices, how these mobile devices is the part of our world, right? Without mobile we cannot live for a day, because each and every time we are keep on seeing that. I'm not saying that that is an addiction, right? But the applications nowadays what we have, so that there are so many sophisticated applications which developed and put it into our system to utilize the IIoT enabling, right? So the world is towards IIoT, right? So I believe that within 5 years, most of us will be part of the IIoT enabling, right? That is what my request as a from my industry point of view. So we felt that still there is a, deficiency in the people who are really get into the electronics, like embedded kind of thing, and they can develop the sensor. Because let us assume in industry there are most of the devices now in the mechanical sensors. If you assume that if you want to change that mechanical sensors into IoT sensors, how much efforts is needed, right? With so because if the competition comes, then only the price will go down. So that is the request towards you team, right? You are the one who is going to create the future of the people. So for physics or science or any kind of science related students, you are going to create them, right? So that is my up to this. This is the first use cases what I have prepared. Probably I'll hand over this session to Dennis. So he will bit explain about how we are doing in the solar industry, right? So Dennis, probably you can take it over now.
Thank you, sir. I'll take the
Thank
session.
you, sir. Thank you, sir. And welcome, Mr. Dennis. Welcome.
Thank you, ma'am. Good evening, everybody. And I'm here to explain the use cases about IoT application and enter-enabled power. But to be very specific, I'm going to explain about how it is much adopted or utilized in solar industry. So, okay, before diving down deep into the application of IoT into solar industry, I would like to give a glimpse of how the industry or production unit works with Industry 3.0. I mean, hope Mr. Kudiaras has gone through quite deep, but I'll just give an overview. And even there was a questioner about how IoT in shipping industry works. So I think this could answer. Every company has this setup for sure, and the least data shared among these units are from this local SCADA and PLCs, which are production. So the ERP system, which holds the production plan or the stock values, they don't have the exact
Sorry,
amount.
Dennis. Sorry to
Yeah,
interrupt. I think you're not sharing.
it's
We
not
are
clear.
not able to follow that.
Okay, just a minute. I'm sorry. Is it visible now?
Yes, sir, it is visible, sir.
Perfect. Okay, I'm so sorry. So, okay, I'll just write up with CRM. CRM is customer relationship management, which plays key role in sales and marketing, and they are directly related with the production unit. But the data transmission between all these units happen with either with Excel sheets or hard documents, and everyone from the payment or from the logistics and supply chain, the movement of materials, all happens as independent silos. They don't really interact with each other. If a boss sits at the top, he has to get manually the data from each and every department, how it works or how it functions. So he don't have like, he's not very few clicks away from retrieving data. Okay, then it comes to the manufacturing part. The PLCs are nothing but IEDs. They are smart enough to decide to run the logics and manufacturing the products. And the low level devices or the field devices or the sensors, and data gets into local SCADA, and we do all the normalization, storing, clearing up data, and how it functions, and we do all that stuff in local SCADA machines. So imagine if a company has like 5 or 10 sites across the India, production sites, and they don't have integrated platform to mingle all the data or monitoring how the production works or the company works. So for that, the industry has evolved to 4.0. Okay, I can compare when the man discovered bicycle, the mechanical movement. It's a leap for mankind. And similarly, Industrial 4.0 is going to play a vital role in efficiency of production. And you can see, Mr. Elon Musk, how he transformed SpaceX into most successful rocket launching private company because he adopted the most digitalized way of working and ensuring the products in a more sophisticated way. So, and this is 4.0. Okay, forget about MQTT. So I'll just take it as a IoT device. So which connects from CRM, ERP, you name all the divisions. So it can collect the data and it can publish it to the required parties. So how it does? MQTT is the IoT device should be bidirectional. So the data is collected in the machine learning devices, which is either it's a cloud, it's running in the cloud or in the local servers. So they decide upon what is the requirement of the client, how much orders we have, and what is the production line, what is the logistics we have. Okay, there is a short of materials on our site, and we have to order new materials, and it's sent to ERP to raise the purchase request. And if we have short of cash and we need to go for collection from the customers, it triggers the message to CRM. And the local SCADA, performance, how much the wastage from every production unit, what is the production rate we have for imagine small gadgets. For if it is like 1000 gadget per hour, the plant cannot run at its peak production. So anyway, it has to it will be running at 80%, 90% of its total capacity. And if there is less orders, how much the production rate has to be. So all all these things are decided by machine learning. So it doesn't happen just overnight. It's a collection of data, storing of data, cleaning up data, and the machine learns the patterns, how it works, how much orders, and how much, what will be the production rate with the quality of materials we have. So this is how the whole industry or whole plant works as a single unit. So no matter it is located in India or in Spain or in Denmark or in US or in China, so everything collaboratively works. So the material movement between the regions or the units or to the customers are very well monitored. Okay, when it comes to solar farm, these are the very low level field devices. So where we use IIoT very extensively, because we may come across a lot of solar farms in India. India is revolutionary in making green energy possible, comparing with other countries next to US and China. And when it is solar farms, I could say roughly 1 megawatt of solar panel installation would take up to 3 or maybe 3.5 acres of land. So imagine a Kamudi in Tamil Nadu has 648 megawatt of solar plant, which is second Asia's largest before. I'm not sure about present. So you can imagine how much the spread it has, and the monitoring of each string is very critical in which defines the entire production of the plant. So the solar panels are divided on strings. So they are connected to a string monitoring junction boxes. So how this is done? The inverters or depends on their capacity, the number of string monitoring unit boxes are decided. So they are connected with 18 or 16 or 17 pallets of solar panels. So it is very much enabled in reading the specific current produced in the panels, the cumulative current, the voltages, and even more sometimes temperatures of the panels. I'll tell you why the temperature measurement is much critical here. So these data are collected and sent to and they are communicated to the SCADA system or maybe MQTT broker, and that's how the whole plan can be monitored. The plan site inside there can be like 2 or 3 persons in the for maintenance. If for every SMU, example, 8 megawatt of plant can have about 80 to 90 SMUs spread across the sites. So it's not possible for the human being to go and check very frequently. So what we do that there in that place, IoT comes into play in monitoring very efficiently and reduces human work and energy management. How much energy is produced in each and every plant, and how much is exported, and what is the transmission loss. So the transmission loss is questionable, and it has to be kept under control. Active power management, reactive power management, it's all the critical parts of energy management. So the digital monitoring meters are connected to IoTs, and the data are collected, and any remedial measures are taken immediately. And then comes the temperature management, and we have temperature measuring sensors in maybe like 3 or 4 places in a site to measure the temperature of solar panels, especially during summer, because we know the sun heats up, gives a lot of irradiation during summer season, especially in dry places. So the panel gets heated up eventually, and what happens, the energy production or power production has its own threshold. It goes up to a certain level, and when the panel heats up too much, the production falls down. And for that, temperature measurement is very, very critical. And next is tilt angle using tracker. Some the rigid geographic locations have the flat way of installation of solar panels. And if it is very clean and very smooth, the solar panels are installed with the tracker. And the tracker, what it does is from the sunrise to the sunset, it tracks the sun. And which means it will be on its peak production till the twilight. It always turns towards the sun, measuring the maximum irradiation emitted. So, um, you know, the tilt angle will be staying same for maybe 3 to 4 minutes or 5 minutes till the movement of the sun is captured. What if the dump data is keep on coming? The panel angle is keep on receiving, or SCADA server or the MQTT or dumped with duplication of data. So this IoT plays a key role in ignoring the duplication of data and acquiring whenever there is only change in the data. So the tilt angle measurement. Okay, if we have like we have connected like 630 kilowatts of solar panels into a single tracker, and if there is a problem in the tracker or any line, it can be easily detected, and it can be compared with other trackers as well. And next is weather monitoring station. So for the solar farm, the key parameters are irradiation, ambient temperature, and rain measurement. So rain measurements come with counters, how much rain we get during the season, and how many times the cup dips, and ambient temperature is measured, and also the irradiation. The peak production happens between 10:30 a.m. to 3 p.m., where we have a very good sunlight if there is no clouds. And even then we can measure, we have the production loss, or we have a degradation of panels, And if there is any cloud movement or if there is a rain, we can easily compare the data how it performs before okay, imagine the dust has spread over the panel, and after there was a rain, and next day you can monitor the production. If with the dust prevention, what is the loss we had and how much is the production now. So how frequently we need to clean our panel and what is the deviation we have. So all this micro level data can be gathered with the weather monitoring stations. And wireless communication, this is very most efficient way of communication across the solar farm, since it is spread over to the vast land and across all rigid terrain sometime. And we have RF communications and all the IoT devices as their um, gateways, and they communicate directly to the RF modem. It's omnidirectional, so it can communicate and collect data from all the directions, and we can efficiently monitor in local SCADA system and IoTs. Okay, this is like legacy data collection method. So mostly it was like so fanciful in running cables between all the devices, thinking it's so fail proof and it will be very rigid. But sometimes we come across disruption in the communication. Either that's a human digging happens, and someone digs up for a farm, or the rat bites, or we got all these cases. Squirrel lives in some SMU boxes and cuts the cable. And since it is running in a series way, if there is a disconnection at one point, it disrupts the entire chain. And the SMUs connected after that will not be sending any data, and we would not be knowing where the disconnection happens and why it happened, and it takes a lot of time and man work to restore the communication. And for this, we came up with IoT enabled wireless connectivity, which I was telling you about SMUs. So in this one, all these SMUs are spread across the sites, and every SMU works very independently. So this is the site. This slide has the entire site architecture. So this is like a one site, and we have RF tower which operates on 2.4 gigahertz. And imagine there are a lot of number of IoT devices, and here is the MQTT. And every SMUs or the field devices access MQTT client, and this one as an MQTT broker. And what it does, the MQTT client, it always sends whenever there's a change of data. So it will not change when if the system keeps on duplicating or buffering the old data, it will not transmit. It will transmit only whenever there's a change in data to the MQTT broker, and it gets published there. And there is one more points to be added. If there is a change in configuration in one IoT device, it will get published or notified to all the devices. So all the clients which are subscribed will get notified about the change, and it themselves adapt. And okay, what is the difference? Why we need to have a SCADA and MQTT? MQTT, of course, it runs on SCADA a server, because MQTT broker doesn't need any specific device to be run. It can run on your PC, a mobile, or in server. Okay, I'm having MQTT's broker in my SCADA server, but the SCADA system, it asks for data. It asks the devices to send the data, and it sends the request at what frequency it needs. Okay, I need the data from SMU for 1 second. From inverters, I need like from with a range of 5 seconds. From energy meters, I need, if it is 2 minutes or 3 minutes, it's fine for me. But MQTT, it's getting the MQTT client, they pushes the data to MQTT broker, and there is a two contradictory differences between the SCADA system and MQTT. And SCADA system has the complete architectural built from the application layer. Okay, what if there is a data transmission happens and the disconnection in RF, or if there is a failure, or if there is a failure between the SCADA system to the central server. The application which runs on SCADA, they don't have the store and forward sometime. But MQTT can store up the data to quite a long time, and when the communication restores back, it will forward to the corresponding end. So this is how the MQTT broker works. Though they run on the same system, it has its own purpose of working. So SCADA system for MQTT, it don't have its own memory. If it need to have a prolonged memory, the SCADA server has to be configured in such a way to accommodate the MQTT data. And this is the Solar Park with 4.0, and it has the entire architecture, how it comes from the field devices of inverters, transformers, MFMs, and weather stations, and number of PLCs. And if you like to get me the number, I could say like 8 to 10 megawatt can have about 200 devices of this IoT devices spreading across. So it's all communicated with RF and okay. Okay. This MQTT, this architecture stays inside the plant site. This is maybe common for all the sites. And this MQTT can act as both client and also broker, where it can receives and also publishes. So if I need to speak about a little glimpse of MQTT where we use extensively on both the sides, it's just nothing but message queue telemetry transport, and it's like a subscribe and publish messaging. So it works on TCP based communication protocol, and it's mostly applicable for all these lightweight machines. So what is this subscribe and publish? So publishing is like, we know we publish something, which means we give something. And subscribing is like what we get it by requesting. So, and it's a perfect communication example for this pub sub model, where this publication subscription model. And okay, to be put it in very in a nutshell, imagine a post office. Okay, we receive letter which is addressed to us, and also we send letters to whom it has to reach, and the post office acts as a center point which carries letters from us and delivers to the concerned person, and also the letters which comes for us. So this is a simple example where MQTT broker acts as a typical post office between all the sites. And why do we need to have this MQTT broker? And it has its own benefits. So eliminates insecure connections. So whatever the connection, outside connections are getting eliminated. And if we have this MQTT broker here, and we can scale up number of devices. So I said like 200 devices. I can add up to another 100 devices, and it can subscribe with this topic. And it has no problem. We can scale up number of IoT devices because it has a reduced network strain. And okay, what kind of network strain I can compare with MQTT broker and the SCADA application? SCADA application works on TCP, and all the devices connected in parallel, and it all fetches the data. So the bandwidth is really, really high, and all the IPs are getting communicated at the same point of time, and it receives the feedback. And here in MQTT broker, the network strain is very, very less, which means the network traffic is very, very less, and it's always managed. And it's always also manage the client's connectivity status. So how much it is connected. So I can say the birth, death, the final will, all the things are stored here, which means when the device is connected, when the device has disconnected, when the device has gone out of service, or when it has got repaired, or the last data, what is stored in all the clients, all these data are stored or kept or fetched in this MQTT broker. And okay, when it comes to MQTT in specific, it's just a software or application that can run in a Raspberry Pi or PC or a server, and even or in a cloud as well. You can have it in your own premises or in some distant server. So it's just like a small application. You can try it on your own mobile or in PCs. So it's all completely self-built, and also it can be third party. It's an open source tool as well. And how it communicates and how it publishes and knows what data it actually requires. So it doesn't uses like if you imagine the Modbus address, so 40,000 series or 30,000 series, it don't communicate in such a way, but it uses topics. Okay, to be put in very easiest way, imagine you have three clients. So there is one MQTT broker, and you are collecting the temperature of you have a topic called temperature, and you are connecting all this client in the MQTT broker. Whichever publishes this temperature or get into the brokers, and whichever the client asks for the temperature, the it gets the changes what it is happening in the broker, which means everything runs with topic. I mean, I'm putting it in double quotes inside. So anyone who wants to have the copy just subscribes to the topic and gets the data. That's it. Very simple as that. And all clients are gone through the brokers, and it's like one to many devices architecture. And as I said before, it is bidirectional. It goes here and goes there. And for sharing, managing and controlling devices, the MQTT broker plays a vital role. Okay, when it comes to security, for internet, we use it in server, and it can have its VPN connectivity, cyber security, firewalls, and all these things. And what about this IoT devices or MQTT protocol? It has this TLS encryption, and also it has its own username and passwords, and optional certification. So this encrypted message and transfer of certificates, and you can open the message and decrypt it. And okay, and also there is an interesting question. Okay, I have a redundant SCADA, I have redundant server, I have redundant hard disk, redundant routers here. What about this MQTT? We always have redundancy, and there is always automatic redundant backup broker available at any point of time in hot swapping all the traffic that is coming in, and also it has its own mirror image to build again from the point it left, maybe within a millisecond. So store and forward options is always available with it, but it comes with a condition again within the double quotes, which means it cannot store the entire log for a prolonged time. It has its own limitation, which there so that we can manage it by sending this MQTT inside the programming inside this SCADA server, with this SCADA databases, so you can store the data. Oh, so now you can see all the field devices. MQTT clients are communicating with the brokers, and the data are collected in the SCADA server. So all these local funders are happening here, and so SCADA server gives the data to unified name server, which means this has the specific model, specific make, the serial number are all getting stored, in this unified name server. Which means if a IoT device goes off, gets faulty or malfunction or disrupted, we can find exactly no matter where I'm sitting there, and I can always monitor and get the data where the things went wrong. And also I'll be getting all the live data and the change of data from MQ to the client broker to the client broker. It can happen in both the way, hand on hand. So just I'm drawing a line in between. So this is how the communication happens from MQ to the broker, and it acts as a client, and this can act as a broker. And from the SCADA, I'm getting the unified name. The operation is getting closed up. So then comes the machine learning part. Reading all the, it maybe it is like 3 levels apart, but This machine learning is closely connected with field devices. And in later days, it will be deciding how this has to function and what are the parameters it has to set. For if it is like controlling the reactive powers, how much point value it has to be set. All the things will be decided by this machine learning because it's learning its performance in quite a long time. So this all the server and MPD data are helping this machine learning algorithm to learn the entire solar park performance. So when it comes to data analytics, it's nothing but just not about the product, forecasting of data. It's also reading the data, what it is saying exactly with the large past performance from the data of commissioning, how the plant is performed, what is the production, and when all it is getting failed, what kind of devices are getting failed. Is it from specific make, or is it from specific model, or is it from specific conditions, maybe lightning or rain or any kind of electrical surges? What kind of failures are happening, and what is the projection for future? How much is the duration of solar panels, and what will be in the few forthcoming years? Imagine I commissioned the plant in 2016. I'll be having data till 2020, and I can project in 2021 and during this July and August, what data I had for last 5 years, and with 5 years of panel derating, what I'll be having in next year. So of course, the derating formulas and the performance of panel will be taken into consideration. It's not only with the data and forecasting of the plant, but also for preventive and predictive maintenance. Because inverters are the most expensive part that plays a vital role in power conversion and transmission. So it's not, and also the transformers. It's not easy to replace because it always consumes cost out of a pocket when it comes to service industry. So we'll be analyzing the data performance of each and every sensor attached to it, and how much it's performing. What are the alarms we are getting? What kind of warnings we are getting? So that cannot be ignored. By analyzing all these things, we come up and we derive with these warnings, the transformer may fail within this number of hours. So we take it down and we fix it instead of waiting for the failure, which consumes unprecedented man hours, cost, and production loss. We can always forecast and fix it in the beginning. So this is how the IoT helps in capturing and transmission and validation of data across all the ends, and which function as the whole. And okay, I'll tell this one is like an analytical model we built for DC loading test. What is DC loading test? I'll put it this way. When a manufacturer manufactures a solar panel, he prescribes the what kind of rating every panel is getting produced, or how much watts of power it will be producing. But will I need to justify to the customer the panel is producing as per the specification given by the manufacturer. So I'll be testing each and every panel into the specific um, production ratio. So, and I'll be finding the deviation between the rated and generated power. By getting the data from string level, from IoTs, I'll be taking the data in like 5 seconds, every 5 seconds, or every 1 second, or every 5 minutes, average data. And I'll be looking at what are the strings are getting failed. Is it connected, or is that a communication problem, or is it the failure of the panel? So I can drill deep into each and every issue, and I can tell my customer, or tell the site people, this is how the whole solar panel or functions, and this is the production ratio, and failure rate can be easily find out, and what is the area. Okay, if there is a tree grown on corner of plant, or if there's a shadow falling on the plant or the panel, if there's a pole and the shadow, it's affecting the production, we can easily find out with the graph and with the data we acquire. But the thing is, we need to drill down to the each and the specifics of the data, by not ignoring the small deviation. We have to always look for the outliers. It's not, the outliers teaches us most than the normal data. So that's how the analytics model works here. And the sample AIs and models, how does it goes? The analytical model for inverter temperature hotspots, the inverter controllers um, are getting monitored from the data, and also we can check for the failure or abnormality of every inverter and compare the failure with the rest of the inverters which got failed in specific format or fashion, and we can drill down to the root cause analysis. And also even okay, I'll tell you, the IoTs can send the data even if the person failed to latch the door. So imagine that kind of data or getting transmitted or produced from IoTs. So it gets each and every parameters of inverters from voltage, frequency, or current produced, and the set points we have, the active power, and all these parameters, and that will be analyzed comparing with the rest of the inverters in the same site or different site, or failures, or the projections or duration, and all the things are done with AIs. And solar panel maintenance. And especially if we go across maybe around Karnataka or Andhra borders, where we have a lot of mining activities happens, and you can expect a lot of dust forming, and the panel get deposited with a thin film of dust. So there is always 2 to 5% estimated loss in power production, and cumulatively the loss can go up to 30% of production loss when there is dust deposition. Uh, and the frequency of cleaning the panels can be always planned and scheduled based on the data. So we always take the reference data, we check the present data, and we can see the deviation, which means the cleaning has to happen. So we tell the site people, just go and check the panels. There is a deviation in the production, and they go for cleaning. And also, this deviation can be easily prevented by frequent cleaning, and how it is happening, and how much production can be boosted with this one. And this has to go hand in hand with comparing the data and its own analysis. So I think I'm coming to an end. So with all the outline of solar power and IoT's data, and before winding up, and there is always technology never resists for transformation from 3.0 to 4.0 or to any technologies. They never resist, but the humans we resist for transformation, for adapting to new challenges. The leaders or the industrialists or the people who adopts to the technological transformation, they lead, they transform the society, they transform the industry. You can count on most successful industries: Boeing, NASA, Tesla, you can name the Toyota. And all these industries, they gone up with scaling up their technology with the future. And that's how the things got evolved. And that's how the technology makes us to be enjoyable with the features we have. So thank you so much for your patient listening, and thanks for the opportunity. Big thanks for the opportunity for all the big hearts for letting us in. Mr. Kudiyarasu, would you like to add on anything on this, please?
Yeah. Thanks, Dennis, for the wonderful presentation. So I would like to add some more. If since most of the professors are here, so if you want to evaluate the IIoT technology, so you don't want to invest much on doing this investment. Most of us probably you may know. So usually in the starting days, how I can do the evaluation in the sense this can be done through the low cost kits which is readily available in the market. Like Raspberry Pi is one of the perfect example for the IoT enabling. I hope most of you may uh, know that Raspberry Pi. If you want, I can show through the camera also, right?
You can do, sir. Yes, sir. You can proceed.
Yeah. So this is the one. So probably I'm not seeing my video. Just a moment.
So we can able to see, sir.
Right. So this is the Raspberry Pi, which is the small computer. So probably most of the guys who are already working. So please excuse me. I want to show this. Those who are all don't know about this, right? This has one Ethernet port and 4 USB port and one HDMI port. So through this you can connect it to the monitor, and it has the SD card. You can connect a 4 GB memory card. So you can run a simple OS Raspbian, and there are so other OS are supported by this board. So you can run a mini Linux, and you can write your own code. Even I wrote a MQTT broker in this, and I have evaluated mobile as a MQTT client, right? So this is a very simple and easiest one to do the evaluations in the MQTT. So if you're reading a concept, you want to use the MQTT technology, just my advice is go with this. And this cost around, you can buy this in Amazon close to 3,000 to 4,000. So this is a mini computer. Even you can use this for a playing games in the by connecting to the TV. So this kind of sophistication we have. Very good 1 GHz processor is this. So and 1 GB RAM. So it's a mini computer. You can use as like a computer by connecting keyboard and mouse, and Ethernet. You can use this. Wireless is already there. So this is one of the product just I want to show. And if you are more interested on embedded, so you can buy the development kits like this, right? This is an ST based development kits microcontroller. So there are if you are more interested in the low power devices, you can go for ARM L0 kind of device. L0 is the least power device. So the series ARM series. So through that you can buy these boards in the online and explore yourself. All the sources are available. Most of the sources available in the open source. You can use this with this. Probably we can share you more links about where you can go and get the codes. So again, I'm seeing the most of the questions here. Probably we can go with the questions, right? I think so,
Yes, sir.
right? So
Yes, sir.
I'll, I think most of the questions, some questions Dennis already responded. Probably I'll see what all the questions is not responded.
Sir, I will read out the question, sir, for your
Okay,
convenience.
yeah, please, yeah, please. So and going to this, some of the questions, if we are not prepared, then probably we can revert it later. Whatever the things, because IoT is the worst area. So we can cover almost whatever we know. No problem.
Okay, sir. So first question is, what software can be used for data visualization from IoT devices?
No, there is no specific software for the data visualization. So the IoT data, the sense of once the data is pushed to the MQTT client, we can it again based on the trade-off. You are going to develop or you are going to use the existing technology. So existing technology may not be readily available because this is your requirement. So what kind of sensor is going to use, that is your requirement. So we need to prepare with our specification. We need to go and see the which software which can support, because in the data collection part, the backend which is handled by the so many softwares. For example, we usually use Kepware. Kep server is the software which used to collect the data in multiple frequency, and this software can store the data into the database all the level it can do. And we prefer the user interface as a open source like a PHP we use. So for the user interface development, right? So we have a teams to develop based on our requirement. They will develop and they will do that. So most of the guys who are using PHP and some other advanced language also there. It will keep on changing. basically. But the data collection part is fixed. So what is the protocol which you are going to support in the IoT sensor? That only we need to see. If you are going to implement the MQTT client in the IoT sensor, then MQTT broker will be there, obviously. So we may write a simple code in Python to send data over MQTT. Right, MQTT is a protocol. So beneath layer, we are going to write some scripts to put data into the MQTT broker. There, in even the MQTT broker also, we can write it in the Python or some other machine language. Mostly Python is the best language to learn, right? Since if you are in the education sector, so Python is the one of the wonderful language you can do all this thing. So,
Thank you, sir. So next question, how do you tell it is going to rain today? Is there any specific meteorological sensor behind it?
no, there is no meteorological sensor available, but there are sites are there. You can the APIs are available. So if you give your let long to that through the API, so that will give the predictions what that is going to rain or cloudy or open sky. These kind of prediction we can get at least for 7 days. Right. The only thing you need to give your latitude and longitude to that API. You can call that API in your script and you can give your let long. You can get those predictions. There is no sensor to give a prediction. The sensor only give the current atmospheric pressure or humidity or the wind speed or the irradiation. This only it will give. Sensor won't give the predictions. Sensor will give only real time. And with the data we can use it. We can build a model for the predictions. So, but usually these models are readily available. Maybe some of them as open source. We can get the access and through the API.
So next question, sir. What is the hazard due to this much of data generation? With cell phones already have, there is a health issues. With increase in IoT, could there be any issues?
This is a bit diplomatic, yeah. So since we obviously the data transfer is more than the impact on the high frequency waves definitely will be more. We need to. It is a trade-off. You need to protect ourselves based on how the distance we are keeping the mobile and how frequently we are using that. Definitely, it will affect.
Thank you, sir. Which softwares are advisable for accessing the data for genetic analysis?
I'm not sure about what kind of data they are taking for genetic analysis. So which type of sensor they are trying to get the data. So probably if any standard protocols, there are so many data acquisition softwares are available, like Matricon, like Kepware, or some other. So many players are there. So data collection, it depends on the protocol, which protocol they need to acquire the data from the base device, data collection.
Thank you, sir. Can IIoT be applied to check the purity of air?
Yeah, anything can be done through. Only thing, the IIoT will be the part of data sharing methodology. So the science is different. So any sensor which is readily available analog that can be converted into IoT. That is my belief. Any sensor which is available in the sensor, like if you are using something in the chemistry lab in the analog way, that can be made, converted into digital.
Okay, to add on to this answer, if you ask for this chemicals, there is a lot of sensors for measuring SOx and NOx, this sulfur dioxide and nitrous oxide, and for chemical that pollution that's happening in the air or in water. All these things can be monitored by this pollution control board or central board in Delhi, and they can take necessary action. It's how much we implement and how much reliable the data are, and how we are going forward with fail-proof technology that in turn benefits the user. Thank you.
Thank you, sir. To train AI, we need a very much prolonged data. Till then, how the decision will be made? Will it depend on human interface like Industry 3.0?
Yeah, obviously. So we are we are now moving, we are in the transition phase of 3.0 to 4. So still, if we are not fully migrated, until that we have what we have with us only we need to live. So there is no way, but we'll start keep on putting our foot in front, and we need to go further. So that's why I said in my presentation, this is not a 4.0 is not a matured industry, right? This is the starting point. We are just framing the technology. So we need to add the framework. This is again, this is not everything is planned and everything is matured. Uh, it is a building the platform now. We started building. It will go for a while definitely. So up to my knowledge, we don't have any clear plan when it will be saturated, because technologies keep on evolving. So we need to be agile, and we need to adapt whatever the things come, and we need to develop the solution. That is the main idea of the IoT.
Thank you, sir. Next question. Can IIoT aid in healthcare sector?
Yes, so there are so many devices already there in the healthcare sector. So, for example, the Bluetooth based pulse oximeters, Bluetooth based the running trackers, Bluetooth based so many medical equipments which is already in the market. So, based IoT.
Thank you, sir. Next question. Is there some sort of handshake between sensors and MQTT? Does a sensor get to know that its data has been successfully published to the MQTT?
Yeah, delivery to the uh, node from node to the server. Yes, it is there. It is handled by the protocol.
Next question, sir. What is the level of encryption used in common MQTT software?
No, SSL, it is already there. So SSL over MQTT is already there. So that encryption that they can use. SSL encryption is there.
Thank you, sir. What technology is used to build SCADA applications?
No, it's again based on the plant requirement. So which which frequency you need the data, how large the plant is, what is the number of device connected, what is the tags which you are going to use. This is only going to decide which technology you are going to use. So based on the protocol and number of devices, number of tags, and what is the budget, obviously. So that's one decides the technology.
Sir, I think you have answered all the questions. There is one question, sir. Can IoT be applied to capture the presence of coronavirus in air?
No, if you, that's why I'm telling IoT is the communication medium. If you have a sensor, this will capture. So the sensor part will not come into the IoT. The IoT is basically the communication protocol, communication method. So how we are communicating to the end device, how we are interfacing the nodes. That is the major concept in IoT. So the sensors and everything, which is the existing electronics part, or which is in the mechanical part. So if any sensors, which maybe if the test kits has the facility with the Bluetooth, then we may do that. So in the on time, whenever the test completed, we can on the instant itself we can push it to the server and we can display how many tests get passed. That only thing that sensor needs to be digitalized. That's it.
Thank you, sir. One final question, I think. Sir, any disadvantages of IIoT?
No, disadvantage and advantage. Yes, obviously anything we have a both, right? It's a both side of coin, right? We really need to see what benefit the common people will have. So yes, disadvantages like more wireless connectivity may impact. There is no proof for that. So, but still the study is going on. So definitely impact will be there, and but we need to see the positive side and we need to proceed further. That's how we will get into the innovations.
Sir, I think Karan Kumar is posting one more question. Recently, we have heard of the data leakage from Facebook and Zoom app. How these data security can be assured?
No, data security, again, no one will give 100% data security if you go to the any security agency, right? It is 99%. It is up to, because the hackers, they keep on learning things up to the mark, right? So the things, anything can be broken. In such a case, if the hackers are evolving, then we need to keep on evolve our security system also along with them. So this will happen, and the fix will come, and this is the continuous, not a single one. It is a continuous.
Thank you, sir. One question was missed. Does IoT has application in waste management?
Yeah, anything can be done, right? So only thing, the process need to be identified, and what kind of sensor which is already in the place, that needs to be identified. If everything is there, because IoT, it doesn't have any limitation. The only thing, the sensors need to be identified, and that needs to be integrated in the proper manner. Everything can be integrated in the IoT.
So one more question. Is there any IoT based smart gadgets for security of women?
Um, Not exactly. It is. I don't know. So maybe anything can be developed, right? So only thing, they need to get the location. They need to get some input. I think some of the gadgets is already there, released by the, even by police department also. So SOS, some SOS based apps are already there. So if it is not there, then people can develop without any much constraint, because there are so many very good technology teams are there. They can develop anything if they have a specification.
So one more question. How long does it take to integrate your sensor to IoT devices?
Right. It's depends on the team which you are working on, which type of sensors and which background. What is the end device? If you are going to evaluate a device for a technology, so if you want to do some pilot, so the thing is, you need to find which device and how long you are going to evaluate. Accordingly, you can do that. If you ask me, we want to integrate a temperature sensor into a mobility broker, and you want to see in the monitor from a specialized app, maybe this takes a week time to integrate. But it is not a continuous for the pilot technology evaluation. So if you want to do the complete validation and everything, it has their own software life cycle is there. It has to pass based on it, again based on the company to company, the policy to policy, everything.
Thank you, sir. One more question. I have very much basic question in mind. It's about how Bluetooth or wireless. It's about how Bluetooth or wireless technology works.
No, wireless technology in the sense, if you are following the TCP IP, then it is a standard protocol like the 7-layer stack. So, for example, in the Wi-Fi is literally following TCP IP. Bluetooth has their own task, own stack. So, only thing you need to do, you need to understand about the stacks, right? So there is a RFCs available for the each and every protocol. If you are going to develop a product, you need to go through the stacks, and you need to implement those in your software. So again, there is a standards which is already given how the protocol is working. It's not a single line or two lines. So there is a standard RFCs. RFC is the document which you need to go through it, which is available in the online. The RFC number will be there. Each and every protocol you have RFC numbers. Through that RFC numbers, you can find a procedure how the protocol is developed and how it needs to be implemented. For each and every protocol, you have the RFC document.
Thank you, sir. Another question. Can IoT be applied for solar vehicle? Why a solar vehicle doesn't take up a lead?
The solar vehicle, maybe it's again based on the battery. Solar vehicle will not be any constraint. So probably will come in the future. The solar and electric vehicle is the future, right? So it has their own time and market restrictions. So everything is there. The cost is also another factor. So solar panel, high efficient solar panels, and the battery will be the game changer. So in near future, you will see that once battery technology evolves in India, then obviously everything will picks up.
Thank you, sir. One more question. What is the biggest challenge in creating an IoT gateway solution?
IoT, sorry, IoT gateway solutions in the sense if you are going to develop a product, IoT gateway. So it depends on which technology you are choosing, right? If you are developing a gateway to collect the serial-based devices, right? That that won't have much complexity because these serial devices will push the data in less in quantity and everything. If you are going to select the higher volume of data, then you need to concentrate on the recurring polling. So if you have to run a multiple task inside the gateway and you need to collect those data. So it's again the specification only decides which type of application and then the semiconductors which you are choosing, right? There are n number of semiconductors players are there. There are n number of features are there, like ST, analog devices, TI. So many semiconductor manufacturers like ARM. It's again based on the competency level of the design team and the experience of the design team. So that's how a design team like in the hardware as well as software. Once you
Thank you,
have
sir.
clear goal and so competent team, so everything can be possible.
Sir, one question. Brief about the working of SOS systems or apps.
Probably I'm not expert on the app side. I'm basically working on the communication of IoT and these things. Probably I'll get it and I'll share it.
Thank you, sir. One more, sir. What is IoT based WSN network?
W.
SN network.
Okay.
What is IoT based WSN network?
Okay. So I'll get back on this. No problem.
Okay. Can I move on to the next question, sir?
Yeah, please.
As a life science person, can I decide my own protocol for a given problem, or what is the requirement?
Yeah. So yeah, initially I was in embedded. So we also interested in developing the own protocol. Yeah, that is everybody is willing to do that because they want to do something on their own, right? So that is ultimately it is recommended. Okay, if you are going to interface your device with your another like a master slave. If you are also developing a master and you are also developing a slave, that is recommended for maintaining the privacy. But if you ask me as a common integrator or anything, but I won't advise to do the customized protocol. Any products which you are going to develop for an industry or for a world, so that should be open. So it is better to have a open protocol like Modbus, right? If you implement this protocol in your device, what you are developing, so that will help the society to integrate these devices into their system. So that is what my recommendation. Yeah, obviously for learning purpose you can do and you can develop your own protocol. There is no constraint on that. But as a common man, as a integrator, we believe that the people should go through the open protocol. That's how the world is going on.
Thank you,
Thank
sir.
you, sir. Thank you, sir. May I request our moderator, Hemi? It's
Ma'am.
already 8. It's already 8. Can we do up the final formalities and finish it off?
Yes, ma'am. Sure, ma'am.
Yes. Thank you, Skudiyar sir and Dennis sir. It was really like a teacher and a student. You have done a great job. Thanks a lot for this. And
Thank you. Thanks for this opportunity.
yesterday's speaker, Dr. Mr. Krishna Venkatraman, he just had a chance to listen, and he has said, "Is that Kudiyar sir is working in any college as a professor?" He asked. I said he is working for Siemens. So hats off to you, sir. Thank you.
Thanks, Venkatraman. I also enjoyed your presentation yesterday. It's a pleasure for me.
Thank you, sir. Over to
Thank you, speakers, for your very informative session. Now I would like to invite Dr. Vasumati, Assistant Professor, Department of Physics, to propose the vote of thanks.
Good evening to all. James Allen said, "No duty is more urgent than that of returning thanks." With this quote, I would like to thank our distinguished speaker, Mr. Kudiyarasu and Mr. Dennis Gerald, for the excellent presentation, and you both made the session an interesting, informative, understandable, and meaningful one. Thank you, sir. It's my duty to thank all the participants for their active participation. Once again, thank you all. Thank you.
Thank you, ma'am. Participants, for your information, assignment and feedback link will be posted through mail and WhatsApp group. After receiving the link, fill up the forms within 6 hours. The participants who has given most correct answers will be awarded. I repeat, assignments and feedback link will be posted through mail and WhatsApp group. After receiving the link, fill up the forms within 6 hours. The participant who has given most correct answers will be awarded. Thank you all. Today's session is over. See you tomorrow. Have a good night.
On and off.